Okay, so welcome to the webinar from MSEC. It's the first webinar out of several webinars that we are planning to do in the upcoming months. First of all, I would like to introduce myself before going to extend details from the project. I'm Vanessa Clemente. I have a bachelor degree in business administration and a master's degree in global management. Since 2015, I have been working for the IT sector, and in 2018, I joined Worldline as business developer and project manager at the Worldline Mobile Competence Center. I'm currently involved on different research programs. Among them, I'm the European coordinator of MSEC project, which is the main topic of today's webinar. So during the next, let's say 50 minutes, I will be explaining an overview of the project, main challenge, solutions to address this challenge, and use cases that will validate the MSEC infrastructure. If you have any question, please use the chat from Zoom or wait until the end for questions and answers. On this webinar, some partners from the project have also joined, so we will be happy to answer any question that coming from you. I would like to mention that on the upcoming months, the consortium will be conducting additional webinars more focused on GDPR and PIPA compliance. Use cases also from MSEC will be detailed with additional information, and technical partners will explain more accurately the state of the art and the secure mechanisms and tools developed within the frame of the project for each of the IoT layers. So if you are interested, you can subscribe to our newsletters to get notification about upcoming webinars and relevant initiatives of MSEC project. I will show you later on at the end of the presentation how to subscribe to these newsletters. In addition, if there is no time for questions, you can always send me an email and I will answer your questions as soon as possible. So MSEC is a Europe and Japanese R&D project. It's co-financed by the European Commission under the AIDS 2020 program, and the National Institute of Information and Communication, which is a national research and development agency specialized in the field of information and communications technology that promotes innovation and research in Japan. The MSEC Consortium is a strong partnership of leading European and Japanese universities and research centers, as well as companies specialized in big data, IoT, cloud computing, blockchain, and all of them have actually an extensive experience in the smart city related projects. The overall MSEC Consortium is made of 12 partners, 6 from different European countries. We have Spain, France, Greece, and Ireland. And we have 6 partners coming from Japan also. The consortium is represented by 3 large industrial groups. We have Worldline, NTTEs, and NTT-DMC. We have also 3 universities. We have Keio, we have YNU, and Waseda University. We have also 3 research institutes, which are ICCEs, CEA, and NII, and 2 small medium enterprise, TST, and F6S. Along to this, we have also 2 commit cities, Santander as a full partner of the project, but also Fujisawa, which is a city in Japan, that is fully committed to give its support to the project, facilitating the implementation and replication of different pilots. So what is MSEC trying to solve? Well, a great deal of state-of-art of the IoT systems in smart cities tends to be built around the concept of IoT cloud convergence, which foresees the integration of heterogeneous data streams within one or more cloud infrastructures, enabling IoT systems to benefit from the scalability, performance, and capacity of the cloud. Nevertheless, these solutions, these architectures promote a centralized data collection and processing approach, which introduce several limitations. On the one side, they are inefficient in handling actuation and control over sensors and physical devices. They are prone to complete failures since they dispose with centralized control by a limited number of administrative entities. And they are inflexible in the comparison of the innovative business models and applications. Moreover, in modern smart city applications, there is an emerging need of end-to-end security, since many data sources may contain sensitive information that raise issues on privacy and data protection. The security and privacy issues should be addressed in all the layers to ensure an end-to-end security and privacy. For instance, many smart city applications are utilizing data streams such as image, for example, from cameras or mobile applications. And this stream should be protected from attackers in all the layers by, for example, hijack protection mechanisms in the sensor devices. But also securing IoT gateways, connecting the device and the cloud, data encryption and access control in the cloud, and of course, securing applications utilizing this data stream. Before going to the solution provided by ENSEC, I would like to provide a few insights about the IoT security market. According to IoT analytics reports, most of the breaches were caused by malware, 24% actually, followed by human factor, which is main in the middle, represents 22%. Brute force also represents 80%, and finally 50% is related with denial of service. Another interesting aspect covered in this report is about the importance of IoT security in smart cities. A smart city is one of the fastest growing segments for the IoT security. So a key challenge for IoT towards smart city applications is ensuring the reliability and incorporating issues of ethics, security, robustness, and flexibility to rapidly changing environmental conditions. Without guarantees that the interconnect objects are accurately sensing the environment and are exchanging the data and information in a secure way, users are reluctant to adopt this kind of solutions. Actually, in 2017, about 49 millions of USD were spent on IoT security in smart cities. This number is expected to grow 10 times to $435 million in just 5 years. Ransomware attacks. So it's in 2018 actually 30 million IoT attacks were done. This represents a 200% increase respect to last year, so respect to 2017. So of course there is a need to provide security mechanisms for IoT applications. Third driver is about the new regulations. So there has been on the past years many regulations that have been introduced. One that is very well known for everyone is the General Data Protection Regulation, GDPR. And this strengthens also for the IoT chains from manufacturers to providers of cloud and applications and so on to adopt security measures to provide IoT applications. The last one, but not less important, it's the technology advancement. So with new emerging technologies such as blockchain, artificial intelligence, machine learning, and so on, it facilitates the development of new solutions focused on protecting end-to-end IoT applications. So now, actually, the main goal of the ENSEC project is to develop and demonstrate multi-layer security technologies to ensure hyper-connected smart city. The ENSEC is a 3 years project that started on July 2018, and it's finalizing on June 2021. So we are almost starting the last year of the project. Since the beginning of the project, we were committed to provide 4 main results. First result is to provide ENSEC a platform, distributed platform, robust and trusted smart city platform based on different technologies such as IoT, cloud, blockchain, and so on, to empower IoT stakeholders to develop and deploy and operate IoT applications on top of our platform. The second result is to provide ENSEC IoT marketplace, an innovative and open IoT market of data that facilitates the exchange of value in form of virtual currencies with all the data collected from the different devices. The third result is to provide an ecosystem, a community of different stakeholders and expert partners where they can exchange valuable information in terms of different challenges and findings on IoT security. And the last one, of course, is to provide a business model that can be replicated and adopted for stakeholders to guarantee its return of investment and benefits. In terms of mission and vision of MSEC, MSEC pretends to develop an end-to-end secure IoT platform upon which stakeholders can build innovative smart city applications on top of it. And as a vision, we try to lay the foundation for the adoption and creation of new IoT security standards and mechanisms. So at the end, what is MSEC offering? Well, we have three main benefits by adopting MSEC. The first one is that we provide a market-ready open source software that combines different components and enhance end-to-end IoT security, from the device to the cloud to the application. The second one is the MSEC ecosystem. As I mentioned before, we will create on this last year of the project a community of MSEC with different experts on different technologies, but also with different stakeholders, that it's possible to create links among different incubators of business networks and universities and developers and share IoT challenges and findings. The third one is the marketplace of IoT data to exchange and monetize IoT data, ensuring anonymity, reliability, and trustworthiness of the available resources. The fourth benefit is that all of our components developed have been and applications have been designed with user in the center of design. So we have taken into account and collect all the requirements from end users. A fifth benefit is that we provide an end-to-end secure framework that goes beyond or facilitates the compliance with GDPR and PIPA. And also this framework with different components is going to be tested through different use cases, 5 in total, 2 of them involving 2 cities, Fujisawa and Santander in Spain. I will explain later. And the last one, of course, is the access of different tools, guidelines to develop secure applications and access to project results. So through our website, stakeholders interested on the project can access to different reports that have been done during the last 2 years by the consortium based on different research, like we have identified risk and threat analysis, the state of art of different technologies, and we provide a lot of information regarding the different mechanisms that have been developed during within the frame of the project. But also we will provide on this last year APIs and manuals to facilitate integration of these components with applications. So as a summary, we can find here the value proposition of MSEC. So mainly, as I said, we try to improve the quality of life in cities by facilitating to public sector or governments and health councils and city to safeguard their infrastructures through our secure framework. We also test the different components by 2 cross-border use cases in Europe and Japan that will validate interoperability, efficiency, and data protection principles, and strengthen collaboration and cooperation beyond the borders among countries. We also provide with our components, or we make development much faster and compliance with regulations. We provide the access to the different results from the project. Our architecture has been designed in a modular way to make it possible to re-architect as the need changes. We also provide a freemium model. This means that we will provide access to test these different components for free, of course, with some functionalities that will be premium. We provide this community where you can join free and exchange information with different expert people on this area. And another point for value proposition is, is that we try to stimulate policy innovation and provide information about data protection regulation and how the users and the companies have adopted this kind of regulation, which is still the main challenge on today's. And all of our solutions, as I said, are proven solutions. So here we can see the MSEC architecture, how it has been designed. So security and privacy, as I say, is considered in all the layers of the system, from the network level to an application level. MSEC first provides application level security. So applications and software components running on IoT devices are proved to be secure. We provide tools for designing and validating secure applications. Second, we introduce device level security. So we provide intrusion detection mechanisms and vulnerability detection systems for IoT devices. And then the last one is that we enter data security. So this layer encapsulates data flowing through the network into a secure cocoon. So we provide a lightweight encryption scheme, we provide blockchain mechanisms, and sophisticated data access controls. I'm gonna go more in detail in terms of the different mechanisms and components that have been developed within the MSEC. Here we have on the one side the different applications that will validate the different secure components. I will explain it in all the different use cases. And in terms of mechanisms and components developed, we have grouped them in different functional groups. So we have components that provide development and security designing tools. We have components to secure the city data access, to secure the trust storage, secure the device. So at the end, what we get is an end-to-end security. So if we go to the first layer, development and security designing tools, you know that a vast amount of knowledge is required usually for secure software development. However, all software engineers are not generally security experts. So as a solution to this problem, we propose a framework for building a body of knowledge and construct a knowledge base for secure software development. So we provide security requirements modeling support systems and a model system transition analysis to eliminate both human errors on the designing of the applications, but also to reduce the number of tests that has to be performed to verify the security level in the application. A second layer is regarding the secure city data access. On this case, there are an increasing number of smart cities platforms being proposed in the market by different vendors. However, these solutions are often locked in by design and can share data with one another, which cause market fragmentation and poor user experience. So for that, we provide SensiNAT, which is one of MSEC components that is designed to allow those platforms to interoperate and benefit from the richness of variety. SensiNAT also has been enhanced with a fine-grained security mechanism to allow access to services by only authentified and authorized entities. In terms of Chaos Foxfire, Chaos Foxfire provides a practical distribute and federate infrastructure for IoT sensor. So the data can be shared among various users and organizations in a way that is scalable, extensible, and easy to use and secure. And the last component here, it's mainly related with privacy management tool. As I mentioned at the beginning of the presentation, there are a lot of smart city use cases that involve to record with a camera a different image from the city. And this may contain sensitive information, for example, the identification of a person. So in this way, we have developed a tool which is called Anonymizer. It's a technology that automatically deletes personal information contained in that image or video using artificial intelligence technology. In the third layer, we have the secure and trusted storage and the IoT data marketplace. So for the secure and trusted storage, you know that as digital world, ensuring that the information remains secure, private, and authentic has become actually an ongoing challenge. Using blockchain, some of these issues can be addressed. However, once that the data is stored on the blockchain, it can be manipulated or altered. For that, we have developed a parallel system to the blockchain for the encrypted storage, where sensitive data is encrypted together with a hash. For that, this hash provides the verification if the data has been tampered. So this hash is stored on the encrypted database, and thanks to the MSEC blockchain middleware, it's possible this kind of synergy between on-chain and off-chain data and access control through enhanced transactions and metadata handling, providing anonymity through the Know Your Customer service, and enabling the extension of the system with higher level services such as the trust and reputation management that I will explain later on, and proof of location mechanisms. In that way, since we have this connection between the blockchain and the, let's say, off-chain database, so sensitive information is stored in the encrypted off-chain database, and with the blockchain, we have this kind of hash for the data tamper proof. On the other side, for all the anonymized data, this anonymized data is sent to the IoT data marketplace, which allows users to exchange information through the use of virtual currencies. So the marketplace, as I mentioned before, use a trust and reputation model engine. That actually this works in the sense that aggregates all the information properly and computes a score for every peer in the network. Once this is done, it selects the trustworthy or reputable entity in the community, providing a certain service for the user to interact with and assess a posteriori the satisfaction of the user with the received data set. So if the score for this data set is lower, the user will be punished. And if it's positive, it will be rewarded according to the satisfaction obtained by the data consumer. So in this sense, we ensure that all the content stored in the marketplace has been evaluated, and in that way we provide trustworthiness of several actors participating in this kind of exchange or sharing of data. In terms of security in the IoT device layer, due to the explosive growth of Internet of Things, billions of IoT devices have surfaced in all aspects of life. This has provided a harvesting ground for bad actors to attack and compromise IoT devices that can be used as botnets for further attacks. So we have developed different mechanisms to ensure confidentiality, integrity, and availability, to ensure security of IoT devices using defense in-depth mechanisms and threat monitoring, to secure elements for authentication and encryption, and we provide multi-layer security against malicious activities and violations. So for the first two components, we have developed intrusion detection system and monitoring and visualization tool, which protects vulnerable IoT devices from malicious activities and provides security against these kind of violations or cyber attacks, along with security health checks. The concept of intrusion detection system is not new because there are plenty of systems available in the market. However, most of these systems are designed for upper-end systems. In this approach, the focus has been on providing a solution that can be replicated and can be customized for resource-constrained IoT devices. The second element is a secure element, which is embedded in the IoT device. In this case, with the secure element, we can handle the integrity of the device during the boot process and the authentication and encryption for external communication channels. Finally, we have the end-to-end security, where we provide interoperable authentication, accounting, and authorization in an interoperable way. So this security management tool has been also integrated in the middleware of Soxfire and Sexinat, that it's a middleware connecting applications with the cloud. And they are completely secure right now. And it's a tool that with this we can authenticate devices, data from device and users and cloud to build trust over the whole architecture of the system. So here we have some of all the technical components and mechanisms developed for each of the IoT layers and end-to-end. So just a summary of this technical part of the MSEC project. We provide remote attestation, trust platform module, and intrusion detection systems. For the different images that can be collected from different IoT devices, we provide this anonymizer tool that allows to remove personal data in streaming. We provide also a visualization tool for threat monitoring and health check, an extraction layer to hide the heterogeneity of IoT devices, and we make exchange data with the anonymous subscription function, so allowing all the anonymity needed for secure the system. In terms of the cloud, of the storage, we provide this kind of system parallel to the blockchain that allows to store sensitive information of chain, but connected to the blockchain that provides kind of hash for data tamper proof. And then in terms of application, we provide different tools for designing and developing these applications in a secure way and minimizing the human errors and the tests needed to perform to verify the application security. For this slide, the MSEC project, as I advanced at the beginner, will be validated in two important European and Japanese cities. Each of these cities has been recognized for having already developed a long-term smart city approach. So on the one side, we have Fujisawa, which is one of the Japan's smart cities. It's focused on local citizens, wellness, as one of the themes of local city planning. And on the other side, we have Santander, which is located at the north coast and is the capital of the autonomous community of Cantabria here in Spain. So in total, we have 5 different use cases that I will explain briefly that will validate all different components that have been developed within the MSEC project. The first use case is secure IoT devices to enrich strolls across smart city park. So the city of Santander is trying to carry out an effective policy for environmental management through the signing of agreements that aid improvements in air quality and quality of life for its citizens. Therefore, several IoT devices will be deployed in the coming months, initially in September, since we have had a delay due to the COVID. But these devices will collect environmental data. The deployment of different IoT devices in the different select areas of the city park will fit the park guide application, so allowing citizens and visitors to obtain information that enrich their park strolling experience and making possible also for visitors to visit these spots and perform derive in taking effective actions based on knowledge and knowledge obtained from the measurements collected. From these IoT devices will be deployed, it's possible to collect reports of noise, pollution levels, evaluate the CO2 emissions, temperature, and also the occupancy levels of certain spots in the city. So in this case, all this data will be reported in a heat map that will suggest people, citizens, to check if in specific areas there is a high occupancy level of citizens, and then they can go to another area of the park that it's more empty. So for what we are trying with this use case is to this data may contain sensitive information, environmental data, and attackers can tweak these values registered by IoT devices. We need to secure integrity of this data. And for that, with NSEC, this use case will be benefit of having security features in the IoT devices that will prevent external attacks. And also it's going to introduce, as I mentioned before, some blockchain techniques that will contribute to foster the participation of end users and improve also the system effectiveness. For the second use case, it's also carried out in the Santander city and intends to face the main challenge of the rapid increase of elderly population during the past years, caused by the increase of life expectancy due to medical and social and economic advances. So in this case, aging people may feel isolated due to the lack of close family ties or the result of living alone. So this pilot focuses on home activity monitoring through the use of different sensors, such as presence sensor, bed occupancy sensor, window door open sensor, and smart plugs. In this case, teleassistance operators, through this kind of dashboard that collects different parameters from these home sensors, will be able to monitor elderly homes with the aim to improve the quality of life of elderly people living alone and conduct decision-making based on rules and alerts configured upon the activity collected by different home sensors. This case obviously involves processing sensitive data, such as the activity happened in a specific user home. So sensors to be deployed have a lot of personal information that an attacker can use to track. For instance, for example, with the sensor of motion sensor, it's possible to know if a specific user is at home or not. Therefore, data security is one of the main issues on the applicability and scalability of the solution. So by using MSEC, it's possible to go beyond compliance of GDPR by adding additional security measures to prevent external attacks. This use case benefits, for instance, of the parallel encrypt system for data storage connected to the blockchains to ensure data tamper-proof. So in this case, we make sure that any value of the different IoT devices collected have been tampered, and all the values are correctly to be processed by the different teleoperators of the teleassistant company and take the proper decisions to monitor the different aging people. In case of use case 3, this is the secure and trustworthy mobile sensing platform. This use case is going to be pilot in Fujisawa. And this use case provides a client application that allows urban environment monitoring entities, for example, local governments, to visualize environmental data. Using the application, the entities are enabled to better serve their citizens with sophisticated environment monitoring. In this scenario, an automotive sensing platform is used to generate real-time environmental sensor data streams for all over the city of Fujisawa, leveraging 100 of mobile sensing trucks. So the kind of data that will be collected, it involves air quality, temperature, humidity, and also driving recording videos to check the status of the different roads, if they are unimpaired or marked. And also it includes data collected by government employees, like photos of illegal disposal, graffiti, or that kind of data, and data collected from different websites such as weather, traffic, parking, and so on. This use case illustrates how the MSEC platform secures such a mobile sensing platform by meeting the following objectives. First, the heterogeneous components involved in the data stream dissemination are secure, so they are not cracked by malicious attackers. Second, the data streams are secure also, so they are not tampered in the network between their source and their destination. And finally, the data streams don't harm citizens' privacy, thus an automated privacy protection mechanism is provided by MSEC. The fourth use case is going to be pilot in both cities, Fujisawa and Santander. It's a cross-border use case. This use case is mainly focused on providing an application for end users to exchange pictures in specific themes created by the city, for example, wonderful city spots, gastronomy, and so on. So for that, we also need to exchange this information in a secure way. So users are not reluctant of using this kind of application. And for doing so, we use MSEC also, the different mechanisms, in order to provide this privacy protect mobile participatory sensing platform, in which users can share this information in a secure way with this kind of privacy protection mechanism. The final use case is also in Fujisawa and Santander, and it's about the smart city data marketplace with secure multi-layer technologies. Recently, business opportunities are expected in various situations around the world. Not only IT industry and financial industry that have traditionally used data, but also other business. In addition, it's easy to expect that even citizens buy and sell data as they recognize the value of the data itself for improving their lives and convenience. In such circumstance, data distribution in both domestic and cross-border needs to take place safely and smoothly done to make the data effective enough to contribute in building the smart city. So through this, through our marketplace provided, market participants from IoT devices to humans using mobile applications are able to exchange data and value through the MSEC blockchain implementation and smart contracts. And this marketplace is enabled through several, it enables or it allows the exchange through the MSEC token, which is a digital cryptocurrency. This use case, of course, will handle all the data collected from the different use cases in an anonymized way, but also it may contain some personal information. So we need to prevent any tamper of this data and treat it in a secure way. For that, the marketplace will be operated in a secure environment using MSEC, which we consider the security requirements of GDPR and PIPA. PIPA is the equivalent of GDPR in Japan. MSEC has conducted actually a lot of research on coupling encrypted database with blockchain technologies, thus making the synergy of chain and on-chain storage and processing of data possible, which is a characteristic that enhance security considerable, while still ensuring data reliability and users' privacy. Also, the integration of the trust and reputation system within the blockchain implementation is considered, allowing to evaluate the actual content being shared, thus ensuring that the information can be trusted by several actors participating in this ecosystem. So here, if you want to know more about the project, I have typed here the website of the project, msecproject.eu. You can find different documentation related with the project. We have relevant initiatives, scientific papers that have been published by different partners from the consortium, deliverables that have been submitted during the past years that collects all the research done within the MSEC in terms of risk analysis, threat analysis, and the state of art of different technologies and mechanisms developed within the project to solve this kind of current issues. And here also you can get involved. You can subscribe to our newsletter to get information and stay updated of different initiatives and upcoming webinars. And also you can subscribe to our social networks. We are in LinkedIn and we are in Twitter also, MSEC Project. So this is all for today's webinar. We still have more or less 7 minutes. So questions are welcome, of course. If you have any question, you can, this is the moment. If not, as I said at the beginning of the presentation, this is my account. So you can also write me later or And you can ask me anything that arise from the project. Thank you very much.
Thank you, Vanessa. So we have
also, yeah, it's also welcome if you have, for example, if you have seen any topic that you may be interested. Ideas are welcome. We have to conduct different webinars on the next months, so we can focus a webinar in a specific topic that maybe you would like to know more.
It seems we don't have questions, Vanessa.
Okay, so thank you very much for participating on this webinar. Apologize again for the connection troubles that we have had at the beginning of the meeting. I hope that I have explained myself good. And of course, any doubt or question are welcome always. Thank you.